Look, if you've ever felt like AI is just, well, a glorified chatbot just sitting there waiting for your instructions, get ready. We're officially entering a phase where AI actually does the work for you. Welcome to this explainer. We're moving way past the era of simple chat interfaces and diving headfirst into the age of agentic AI. Today, we're going to break down the mechanics, the architecture, and the strategy behind this massive shift. We're exploring exactly how we transition from AI that just talks to AI that actually acts. Here's exactly how we'll build our understanding today. First, moving beyond chatbots to agentic AI. Then, we'll look at the 4 levels of autonomy, giving AI tools to act, comparing agents versus agentic workflows, and finally, keeping autonomous AI safe. All right, let's jump right into section 1, beyond chatbots and into agentic AI. To truly appreciate the shift, we kind of need to look at how software has evolved over the decades. Back in the 1990s, we had monoliths. These were massive, rigid applications where all the code was just tangled together in a single, tightly coupled codebase. If you wanted to change one tiny thing, you had to update the whole shebang. Then, in the 2000s, we started breaking things down a bit with service-oriented architecture. But the real game changer hit in the 2010s with microservices. Think of microservices like breaking down a giant solid plastic toy into individual Lego blocks of code. Developers could finally build, deploy, and update small, independent pieces of software that talk to each other using APIs. It literally revolutionized the development lifecycle. Now, moving into the 2020s, Agentic AI is taking that exact same concept, but applying it to intelligence. Instead of just breaking down code into Lego blocks, we're breaking down tasks, goals, and brainpower into cognitive components. These new components don't just follow static rules. They can actually reason, adapt, and act independently to achieve a specific goal. It's basically a brand new cognitive layer built right on top of the microservices we've been using for years. So, what's the actual difference between the AI we know and this new agentic AI? Well, the crucial point is that traditional generative AI just waits and reacts, whereas agentic AI proactively pursues a goal. Think of generative AI like a brilliant but, stationary librarian. You walk up, ask a specific question, and it instantly creates a beautifully written summary or hands you a book. But it can't leave the desk, it can't make phone calls, and it certainly can't run errands for you. It just creates human-like content on request. Agentic AI, on the other hand, it's like hiring a highly capable intern. You don't just ask it a question, you give it a goal, like, hey, research our top 3 competitors, put the data into a spreadsheet, and email it to the sales team. It uses a large language model as its core reasoning brain, but it goes far beyond just generating text. It perceives its environment, breaks the goal down into steps, acts on the real world using software tools, and actually adapts if it hits a roadblock. It literally writes its own script at runtime until the job is done. Which brings us to Section 2, the 4 levels of autonomy. As the folks at Vasion put it, autonomy for AI agents isn't a single destination. It's a spectrum of maturity. And it's so important to recognize that adopting agentic AI isn't some all-or-nothing binary switch. It's a really careful balance of efficiency and control. I mean, the temptation for a lot of organizations is to just leap straight to full autonomy, hoping for instant productivity, right? But just like self-driving cars, you don't go straight from a horse and buggy to a car without a steering wheel. The journey and how you manage that transition matters just as much as the destination itself. Let's walk up this ladder, moving from completely manual workflows all the way to a self-optimizing ecosystem. Level 1 is where most organizations are today. No autonomy. This is your traditional rules-based robotic process automation. It's like a train on a track. It does exactly what a human hard-coded it to do, and if something unexpected happens, it just crashes and stops. Level 2 introduces reactive AI agents. Here, the AI acts like an incredibly smart macro or capable assistant. When a human types a prompt, the AI instantly assembles and executes a workflow on the spot. But, and this is key, it only acts when explicitly told to. Now, Level 3 steps it up to proactive AI agents. At this stage, the system acts like a proactive junior employee. It's constantly monitoring your systems, identifying bottlenecks, and actively recommending optimizations. But it still waits for a human manager's final approval before making any actual changes. Finally, we reach Level 4, cognitive. This is full autonomy. These agents independently discover issues, build solutions, and deploy them 24/7. They operate like an embedded operations manager, working continuously in the background under strict governance, without needing constant human handholding. All right, moving on to Section 3, giving AI tools to act.
Let's demystify the mechanics here for a second. Large language models, or LLMs, are ultimately just text predictors, right? They sit on servers analyzing massive amounts of language. They don't have hands, they can't magically browse the internet, click buttons, or log into your database on their own. So, how do they actually take action in the real world?
To bridge this gap, we use something called agentic harness. You can think of it like a middleman or maybe a translator between the AI's brain and your software. The large language model acts purely as the planning and reasoning core. So let's say you ask it to find a customer's address. The AI brain doesn't search the web itself. Instead, it types out a highly structured command, almost like writing a line of code, saying, search the CRM for John Smith. The harness, which is just standard software code running around the AI, intercepts that text command. The harness is what actually presses the buttons. It physically executes the search tool or the API call to your customer database. It gathers the external data, and then it feeds those search results right back into the AI agent's memory. Once the AI gets that new info, it reasons about what to do next. It's this continuous dynamic feedback loop. The AI thinks, the harness acts, and the AI learns from the results. And as these systems get more complex, we can actually assemble entire teams of specialized AI agents breaking down massive, ambiguous tasks just like human teams do. Because think about it, if you ask one single AI model to plan, research, write, and edit a massive report, the results are usually, well, kind of mediocre because it loses focus. But with multi-agent collaboration, we assign specific roles. You might start with a planner agent whose only job is to take your vague request and break it down into a concrete checklist of subtasks. Then, it hands that list to a retriever agent, a specialist focused exclusively on scouring databases in the web without getting distracted. Once the data is gathered, a writer agent synthesizes all those findings into a cohesive draft. Meanwhile, a tool agent might be called in to handle precise, deterministic tasks, things LLMs are traditionally pretty bad at, like complex math or exact word counts. Finally, a critic agent reviews the writer's work, looking for logical flaws or quality issues, sending it back for revisions if necessary. They pass their outputs to one another, iterating and refining the work until it's absolutely solid. Next up, Section 4, Agents versus Agentic Workflows. As we deploy these AI teams in production, we really have to recognize a massive structural difference in how they're managed. While an individual AI agent figures things out on the fly internally, an agentic workflow externalizes those decisions into a structured, trackable process. Let's break that down. Agents are fantastic for dynamic, loosely bounded tasks where you want the AI to be creative and figure out the path itself. But for complex enterprise processes, things like fraud detection or processing insurance claims, you literally can't just let an AI guess its way through. You need an agentic workflow. Think of this like taking that unpredictable AI brain and putting it onto a strict, highly visible assembly line. It orchestrates multiple API calls, specific AI tasks, and manual human-in-the-loop steps within a governable control graph. This means human managers can monitor every single step, enforce the rules, and ensure the AI stays perfectly on track. Looking closely at this breakdown, we can clearly see when to use which approach. Let's look at the architecture and decision-making parts first. A standalone AI agent operates as a single entity with internalized reasoning. Its architecture is essentially a black box. You give it a prompt, and it runs a hidden chain of thought process until it spits out an answer. Because of this, traceability is extremely low. If an agent makes a mistake, it's notoriously difficult to debug because you can't easily see the exact moment its logic went off the rails. It's highly unpredictable. Agentic workflows completely solve this. They are modular and externalized. Instead of a hidden chain of thought, the decision-making is externalized into workflow decision nodes that you can actually see on a screen. Because it's an orchestrated series of tasks, traceability is super high. You get stepwise visibility for auditing. If something fails, you know exactly which agent or API call dropped the ball. It provides adaptability, sure, but with strict guardrails and built-in retries, making it actually safe for the enterprise. Which brings us perfectly to our final pillar, Section 5, keeping autonomous AI safe. Giving software the autonomy to think and act creates entirely new threat factors that organizations have literally never had to face before. One major structural risk is the confused deputy problem. Imagine you have a highly trusted AI agent with full access to your corporate financial systems. An attacker could craft a malicious, hidden prompt on a public website that tricks your agent into approving a fake payment or deleting files on the attacker's behalf. It's using your own trusted tool against you. Then you have rogue agents. In multi-agent systems, if one agent is compromised or hallucinates bad data, it can spread that misinformation peer-to-peer to other agents, creating a massive, cascading chain reaction of failures.
We also have to worry about opaque accountability. If 10 agents are talking to each other at 1,000 miles an hour, their logs become fragmented and messy, making root cause analysis nearly impossible after a breach. There's also the risk of persuasive tools, where an agent might be misled by a poorly written tool description, causing it to take completely unreliable actions. And finally, shared memory leaks. If an agent is helping multiple users, there's a very real danger that sensitive context from one user accidentally leaks into the responses given to another.
But notice how these new cognitive threats map directly to traditional IT security vulnerabilities. We aren't throwing away the architectural security wisdom we've built over the last 30 years. We're just extending it to cover a new cognitive layer. For example, just as hackers used SQL injection for decades to trick databases into handing over sensitive info, they now use prompt injection to trick AI models into ignoring their safety instructions. Hallucination in an AI is essentially the new data corruption. Excessive agency, giving an AI the power to do way more than it needs to, is just the modern version of privilege escalation. And of course, agent data leakage is the new cross-tenant leakage. This absolutely proves that we must strictly apply the principle of least privilege. Agents should only ever be given access to the specific tools and data they absolutely need to complete their current task, wrapped up in strict input guardrails to stop malicious prompts before they ever reach the LLM.
Because ultimately, the winners in this space won't be the organizations that rush blindly into throwing fully autonomous agents at every problem. No way. The winners will be those who climb the autonomy ladder with intention, strict governance, and architectural clarity. You don't have to leap to full level 4 autonomy today. Start by identifying the right level for your tasks, build robust agentic workflows to maintain visibility, and ensure every tool handed to an AI is tightly scoped, which leaves us with one final question for you to chew on. As agentic AI shifts from experimental chatbots to autonomous enterprise infrastructure, how will your organization balance the sprint for maximum efficiency with the need for absolute control?